Okay, so we very quickly talked about buffers last time. So I want to back up a few slides, go over those slides again, tacking a few slides on at the end of lecture. I realize that's not going to stick too much. So let's go over those a little bit again and talk about buffers. So when we had all of these GET requests that we've been doing in homeworks 2 and 3, we didn't have to think about buffers. We would get some information over this TCP socket. We call our receive method, or however our library works, to get information from the stream. It's going to read a certain number of bytes at a maximum, some certain number of bytes, which is the buffer size, at a maximum. But when it's a GET request and it's just a request line and some headers, that request is almost always going to be, and for the purposes of the homework in this class, you can assume that it's going to be smaller than the size of your buffer. So we just call receive one time, we get all the information for the GET request, we process that request, we send our response. Now when we have post requests, and we have file uploads specifically, and that request can contain a lot of information, a lot of bytes, now that is going to overflow our buffers, and we can't just call receive once, handle that request, and then send a response. We no longer have that quick, concise loop in our code. We have to do a little bit more. So if we are receiving, say, a megabyte size file, no matter what library you're using, it's unless you go in and manually change your buffer sizes and stuff, you're probably not going to be able to fit that in your buffer. And let's just say gigabyte to make sure it's not fitting in your buffer. You have a gigabyte file that's not fitting in your buffer. You have to buffer this content and take the request in chunks, stitch all those chunks together, and then serve the response after you get all the information. And this is where the content link is critically important. This client has already been doing this. The browser has already been doing this with our content link. That's why that has been critically important, that we always have content link when we're sending a response. But now we're on the other side of that. We have to really respect that content link. So if the first request doesn't have all the information we need, how do we know when we've read enough information for this request? We read the content link. So we parse the headers, we receive information, take the first chunk of the request, read the headers, look for the content length. I got ahead of my slides a little bit. We're going to read the content length, get that number, the number of bytes that we're expecting in the body of this request. We're going to read that number of bytes and say, okay, if I don't read this many bytes, I haven't read the whole request. So if we get that first chunk, find content length, read all of the body that we have, and if the number of bytes we read isn't equal to the content length, we know we have to buffer, we know we have more information to read, so we have to wait for more information to be available on the stream, or fill up our buffer again, read some more bytes, stitch together to this request, and then we can finally serve the response after that. So we have to read that content length. If we have not read that many bytes, we don't have a full request yet. Assuming nobody's attacking us, nobody's DOSing us, which we'll assume for the purpose of the homeworks, of course, we'll assume nobody's DOSing. You don't have to have DOS protection in these early homeworks especially. Probably not at all this semester at least. So read the content length and then read that many bytes. If you haven't read that many bytes, you don't have the full request. It's critically important. We have to start really paying attention to this in the request, because the content length never existed in our GET request. Post request, this will exist. The post request have a body, has to have a content length and content type. So great, we do all that buffer stuff, and now we support file uploads. This is awesome. We can have people upload information to our server, but there's still one little problem. What do we do with this? So this is okay if you just want people to submit files to your server, then you log onto your server and look at those files. We have that functionality at this point. We have the form with an input of type file. We're reading the content length, we're buffering, we're reading the whole file. Then we can, once we read all the bytes of that file, we can save it to disk and have that file on our server. But that's okay, but we can do more, right? So we'd like to also host these files so other users of our app can see those files. This is usually our use case, at least the sites we'll visit. We tend to visit on a regular basis. Any social media site, the whole point of somebody uploading a file is that other users can see that file. Not just the admins of that page, not just the developers or the people who own that site. You're usually not just uploading a file for those people, you're uploading a file for other users to see in most cases. And even if you're not, you're usually letting the user who uploaded see that file. I'm thinking of Autolab specifically in that. Autolab, you are submitting it for the people who are running that site, for us, to grade, but we're also making that content available. You can view your submissions, you can re-download your submissions. We're still hosting those files. It's very rare, at least I shouldn't say that, I can't think of off the top of my head, an application where you want to upload files just for the owners of that site to access. I don't know, I can't think of a use case for that. Maybe it exists, maybe I'm just blanking, but usually we want to host it too. So how are we going to host this information? When we're uploading images, especially for homework 4, uploading images and then posting those images, how do we do that? We know how to host one image, easy enough. Maybe not easy enough, but by tonight at least, you'll have done that in homework 3, posting one image. How do we host uploaded images? How do we host any image that we don't know when we write our code, and specifically when we write our code, we don't know that these images exist, much less what they're named or anything about them. How do we host those images that don't exist at the time that we write our code? This is the new problem we're faced with. How do we do this? And the answer is by having more flexibility in our pathing. So instead of just saying if the request type is get and the path equals image.png, serve the image, that's what we're doing in homework 3. Now we want more flexibility in our URL and have like something like this, /image/ the image name, and have that as part of the URL, but part that we're going to parse and interpret server side. We're going to look at that part of the URL. So now, instead of just saying if the path equals my image.png, we're going to say if the path starts with image/image, look for this following image, read the image file name, and serve that specific image. Go look for a file with that name. If that file doesn't exist, serve a 404. If it exists, open that file, read the bytes, and serve it like we're doing in homework 3. With the correct content type, correct content length, and all that good stuff. But look for that file with that name that was provided by the user. You could also do this with a query string. For homework 4, I'm not picky, however you can get this done. If you want to do it with post requests, but that'd be pretty gross. You could do it with post requests too, but any way that, and not appropriate. This is static content, it should be get requests, but it's another conversation. But some way to have the user be able to request a specific image, and then we can start hosting these images. We can have, what we'll see when we get to today's topic, HTML templates, have a way to be able to generate HTML with the image elements with the file names of images that have been uploaded by users, so we can serve HTML with the images that have been uploaded to our page. That's our ultimate goal, at least for homework 4, is to be able to have users upload images and have a page that displays all those images. So how do we do something like that? We want to be able to put these URLs in the image elements of our HTML with file names that didn't exist when we wrote our code. It's kind of a mouthful. We got a lot of moving pieces at this point. You can start to appreciate what I mean about homework 4. That's a tough one. Yeah. I'm going to show an example of the buffer also. I'm going to go to my code and show how I do it.
Wondering about content. Does that include the multi-part separator?
Yeah, so the content length is completely separate from the multi-part. It does include the separator. So the multi-part, when multi-part is used, the entire body, all of the new lines, all of the separators, everything in there is just treated as a chunk of bytes according to the HTTP protocol. And then the content type just says, oh, by the way, the content, the bytes that you read, it's going to be multi-part encoded with this separator. According to HTTP, HTTP itself doesn't even care that that's multi-part content. The content length specified by HTTP is just the number of bytes in the body, regardless of what it is. So the fact that it's encoded as a multi-part form, HTTP and content length doesn't even care. And then the content type tells us how to interpret what that information is. Just every single byte in that body, no matter what type it is, including multi-part, is included in the content length.
So if the body overruns both sides, do we just hit a request again, and say, just do the same thing we did to initially read in the first part?
Yep. You're gonna read information off of that socket until you have content length number of bytes. And you don't have to do any processing, like you don't even have to look at the content type while you're buffering. The content length is just going to be the number of bytes in the body, so just read that many bytes. And after you read it all, that's when you can look at the content type and say, okay, now that I have all this, what actually is it? The content length doesn't care what that content is, it's just saying, read this many bytes.
So when you read it, just if it's greater than 0, it's concatenated, buffer.
Yep. Yeah, if you have more than 0 bytes still to read, keep concatenating. Or not concatenate, technical difference here, but it's going to be a byte array, so add it to that, extend that array, create a new array with the appended values and stuff. Because we won't have strings at that point. Like somebody uploading an image, that's not going to be a string, so we can't technically not concatenate. I guess some languages have byte string, maybe they call that concatenation. But the spirit is there. Actually, I think I used the word concatenate also when I was talking about it, so maybe I shouldn't point out that technical point. Let's think of it as concatenation. Sorry, let's not get sidetracked on the technical difference. So we have some string parsing to do. I won't talk about how to do this. It's string parsing. This is potentially a 115, 116 assignment. We could say extract the file name from this URL. Actually, now that I say that, that does make a good assignment. I might actually do that. But this is what you have to do, and you can choose your scheme for homework 4. And as a theme for all these homeworks, you can choose your scheme, your naming scheme, how you do this, how you're hosting your path. All of this you can choose. When you get that file name, like what's your directory name where you're going to look for these images. It doesn't have to be /images, image. You can have the path be /image, but maybe your, which is common in web development, have all your pictures stored in a directory named public. So when you get a request for /image, you're looking in the public directory, directory named public. You get to choose how you do all that. Whatever works best for you, however you want to think about the structure of this. But this is the goal we need to accomplish. Some way for the user to be able to say, give me this specific picture, and then serve that specific picture kind of dynamically. Not, obviously you can't hard code any of this. So give me this picture and how to serve that picture that didn't exist when you wrote the code. Yeah.
User has already uploaded the picture, is that right? Or
But-
do we already have the image?
So you don't necessarily know. So if they request an image, because they can type this URL in, they could type any name here. And if it's an invalid name, that's when you hit them with the 404. I don't think I wrote that spec in the homework. If I didn't write it in the homework, then if your server crashes, that's okay for grading purposes. But that's when you should serve a 404. Like if we go to a website that does something like this, now let's do a quick example. Reddit maybe? So we have this URL, i.reddit.it, their image hosting server, and we have some random name. And this is something I want to mention too. When you get a file upload, you don't know what that file name is going to be. It's whatever the user named their file. So what if you get an upload for image.png, and you save that to your server, and everything's good, people can ask for that image name, and then somebody else, some other user, somewhere else in the world, uploads an image named image.png. What do you do? Which one do you save? What do you do? Do you name that image to.png? There are issues here. There are complications. So what any site that allows image uploads, I shouldn't say any because there's going to be one site out there that doesn't do this, but they're going to generate a name, a randomly generated name for that image, not randomly, deterministically, but some way of generating a name for that image that's not going to conflict with any other name. So they give it a unique name, and then into their database, they'll map that image name to what it represents and everything. But for homework 4, you should be doing this. Generate some name, maybe just start at 1, image 2, image 3. Perfectly acceptable. You don't have to get fancy with the random looking stuff. But anyway, so let's go in here and just ask for image.jpg.
It would be pretty common to use a
And we're going to get,
ASCII image for the name or
maybe, I'm not familiar with the naming conventions that they use, but that sounds like a good approach. Then we'll get some sort of 404. I wonder if this is actually 404. Yeah, so it gave us the 404, and their 404 is just an image that says the image you're looking for doesn't exist. Where are we? Slides. So you have to have some convention. You get to choose how you design this. You can be an architect of your server, but you need some way to be able to serve the images, have the users be able to request those images that they uploaded, that other users have uploaded. So effectively, we have this. We have some path with a file name variable in there. We're going to extract the file name and read the bytes of that file and send the response if that file exists. Now, what if someone requests this? This is the common path for your private SSH key, which if somebody has that, they can do a lot of damage. They can masquerade as you out there on the internet, at least anywhere you use your SSH key. So if they do /image / your home directory, the SSH subdirectory, and then your private key, are you going to read the bytes of that and send that to the user? You definitely don't want to. But if we're not careful about how we code these, when we're taking information from the user and reading information on our server and sending it to them based on what they gave us, we have concerns like this. And this will be a common theme throughout the entire course. Whenever we're handling user data, we have to assume that that data can be malicious. Any path that we expose, the user's going to be able to try things like this. They'll be able to type in, even if they can't, there's obviously going to be no link like this on your site, but they can just go to the URL, like I did with the image, to get the 404, and just type this in. And if you're serving your SSH key, you're in trouble. Or anything else they want from your server, you can get in a lot of trouble like this. So this is something we need to be aware of. Your first line of defense is getting rid of the dots and slashes so they can't navigate around your directory structure, and then have one directory where you're going to read the files from. Don't let them escape out of that directory, and then just put everything that you want the world to be able to access in that one directory. This is why we usually have a directory named public for any website, just to remind us, hey, this directory, everything in here, the whole world can access this because of this pathing. Even if I'm only wanting to intentionally host images from that directory, anything that's in there, they can just type the path for that file and access that file. So just a reminder, it's all public. Let's name it public, just to make sure no developers, no one on the team put some sensitive information in that directory, because that is a security issue. Somebody put sensitive information in there. So making sure you only host one directory and don't put anything sensitive in that directory. two big lines of defense against attacks like this. All right, so let's take a look at some of this. Go back to my web server here, and I want to clear up some confusion. I've got this question a few times. I think going through the homework too, I think most people got this, but just to make sure, just to clarify one last time about this. This looks like I'm using a library. I'm just saying, get this request and run some code, and now just check if the path and method are what I expect, and doing my routing like this. I've said this before, but now that we're far enough along in the course that I'm not really spoiling anything, I can go into this a little bit more. So whenever I receive information, I am calling this line right here, request of r.data, which is taking the bytes of the request and processing that request, as long as I'm not buffering, which I'll talk about in a second. But now I can go into this, since we're a little beyond this in the class. This is code that I've written. I'm not using a library here. Obviously, libraries are banned. I'm not going to show you a library in class and say, I'm using libraries, but you can't. I'm not going to do that. This is code that I've written to do all the parsing that you're doing on the homeworks. So when I create a request, I'm going to read those bytes. I'm going to look for that blank line. I'm going to separate the body and the header. I'm going to iterate over my headers. In hindsight, it's a little silly that I did this, but I just replaced all the /r so I can pretend that there's only regular new lines. I don't know, I just wanted to do that. But splitting on new lines, reading the lines one at a time, reading each header, splitting that first line into method path inversion, then each header looking for the colon, trimming any leading and trailing white space, separating those into the key and value, and adding all those into a map named headers, which is defined down here, some map of string to string. So I have all the headers in this map, and I can just ask my map, hey, do I have a header named cookies? If I do, read those cookies, process those, and things like that. So this is my code. I wrote all this, and then for my responses, I have these methods: send text response. I want the content type, the body, and who I'm sending this to. And then I grab that content type, get the length in bytes, adding my no sniff on there, so I'm telling the browser that I have the correct content types, adding that new line at the end, concatenating the body, sending this as bytes to that client. Same idea with redirect, except content length 0. This was a bug some of you were seeing in Firefox, so I had to go in and do some testing. Firefox wants to see that content length of 0 on a redirect. I don't know why. It was only Firefox that was doing that, but it was causing issues. And then if I want to just send binary and a byte array, I have a way to be able to send that byte array, concatenating this string by converting it to a byte string first, and then concatenating it with those bytes of the body, since I can't do the concatenation before encoding, because I'm concatenating a string with bytes. I need to convert the string to bytes and then concatenate the bytes. Question?
Your requests, class, you have some variables initialized by underscore.
This is Scala syntax. It means not initialized. It means, don't worry, I will initialize this to something, and if I don't, give me an error. But I'm just initializing it to no actual value. And then when I actually create one of these, I'm going to set each one of those values. So I'm going to satisfy that initialization. But in Scala, you can't just declare a variable and not assign it to something. So this is their syntax to be able to say, I don't want to assign this to anything. So when you see this, when I've been showing this code in class, I'm calling request, which is parsing all my headers, parsing my request line and all that, so I can do these kind of checks. And and then I'm saying send binary response, send text response, and that's calling all my other code. But that is my code. I'm not using libraries here. It just looks like that because I wanted to hide all the details because I wasn't going to put homework solutions up on the projector before those homeworks were due. So I just wanted to clear that up one more time, that no, I'm not using the library. You need to be doing everything from getting the bytes from the stream to sending bytes to the stream. Everything in between has to be your code that you wrote. No libraries allowed in that region. Did a quick look in homework 2. I only saw one student who was using a library that they weren't supposed to use, so it might just be wasting my breath here. But I just want to hit that one last time just to make sure it's rock solid. With that, let's talk about this buffer. So when I do read, I do get this request. Before I parse it, I'm going to check if I'm currently buffering. If I'm not, so when this is the first message, the first chunk of data I get, oh, and by the way, in Scala I have this code that's called, whenever I receive data, I'm going to get this received object that I just named R. That's going to contain all the information that was read, all the bytes that were read off of the stream as data. And when this is called, I also have access to the sender method, the sender method, which is going to tell me who gave me this information, give me some unique ID identifying that user. These are two things that you need in your libraries. And before we talk about buffers proper, I want to make sure I mention this at some point. Now is, I guess, the best time. These are two pieces of information that you're going to need in your code. You'll have to have, in your TCP socket server, some way of being able to handle multiple clients. So here I have the sender variable. Whenever received is called, it can be received with a different return value of sender based on who sent it, and also reading the bytes that sender sent, and being able to receive multiple messages from each of these. So your server needs to be able to handle multiple connections, and from each connection, you need to be able to handle multiple messages. So I'm starting to see quite a bit of code that has very poor, improper usage of the TCP libraries that you chose. And this is something that came up earlier in the course. A lot of the questions I was getting about TCP, not a lot of you, but an upsetting number, which doesn't have to be too high of numbers, are saying things like, can't I just cut and paste this TCP code into my code? My answer is always, no, that's academic integrity. What the hell? But the more expanded answer that I always give is, no, you have to understand what that code's doing, because if you don't understand what it's doing, you're not going to be able to use that code effectively. And now as we're getting into homework 3, and you have multiple responses that you have to process multiple requests from the same client, I'm getting these questions like, well, my TCP socket doesn't do it. Well, yeah, because you just basically, maybe you didn't cut and paste, maybe you listened to me and just basically changed the variable names or whatever you end up doing. But if you don't understand what that code's doing for you, which was the point I always make when I answer these questions, if you don't understand what that code's doing for you, you're going to get really, really jammed up at this point. You're not going to know how to handle multiple clients, and you're not going to know how to handle multiple messages from the single client. So how do you buffer if you can't handle multiple messages from the same client, receiving multiple buffer folds from the same client? You need to be able to do those things. This is where on day 1 I was talking about expectations of this course. You need to be able to read, understand technical documentation. And the biggest part, at least at this point, is the TCP socket server. I'm not covering TCP sockets in detail because it's different for every language. If I cover TCP sockets in detail, I basically have to pick a language and say, you are all using this language in this library. I don't really want to do that. I want to leave that freedom out there. So I have to leave that up to you, but you got to actually read that documentation and understand what it's doing, or else you're seeing on homework 3, a lot of you are getting jammed up with the multiple requests from the same client. You're going to start getting jammed up when you want to upload files and then go to another window and make sure you can see those files from another client. You need to be able to handle these things. So if you haven't actually read that documentation and you were just like, what the hell, Jesse? Why can't I just cut and paste? Because, it's just going to be that. That's just how you do it. great, but a lot of those examples just handle one request and one response. It's not going to get you what you need. So just a reminder on all that. And when I say homework 4, I've said this before, homework 4 is a really tough assignment. It's tough if you haven't been doing what you should be doing in the other assignments. So if you did just like, why can't I just cut and paste? If you're one of those students, you're going to get even more jammed up on homework 4 because you don't understand what that TCP code is doing for you. You need to understand what it's doing for you. So here I have the 2 pieces of information we need, the sender, and I have a method that's going to call receive every time any connection, so this handles multiple connections, it's all concurrent code, it's all multi-threaded using actors in Scala. So I'm going to run this code every time there's information to be read from any client that's connected and any number of connections. I'm going to get this R received message, this received object. I also have access to the sender, so I can handle all of my information. I can process all this information the way I need to. So I'm going to check, once I get a request, I'm going to read whatever I have. I'm going to make that assumption that we can make for this class and for the homeworks, that all of the headers don't overflow my buffer. So I'm going to assume that the first time I read information from this client, that I at least have all the headers in the request line. So I'm going to process that, check for the content length header. If it doesn't exist, default to 0. And if it is 0, just process this request and everything. But if it's not 0, if I have some information to read, then start buffering. Oh, and, yep, I knew that was somewhere. I forgot I put it in the same conditional. And if the content length that I read isn't equal to the number of bytes in the body of this request after my parsing for my other code, if that body is longer than the content length, then I need to start buffering. If neither of these are true, then I can just handle the request as I have been before. But if this is true, then I got to start buffering. So what I'm going to do is track 2 pieces of information. I'm going to track the number of bytes that I still have to read, and also the information that I've read already for each user. So I have 2 maps, the buffering request and the bytes I have to read. For each sender, I can store these 2 values. So I'm going to initialize, I'm going to say what I need to read still is the content length minus how many bytes I've just read in this first request. And the information is just what I have from this first request. I'm going to put the whole request in there, headers and all, in this buffering request. These 2 values, these are maps that are going to map my user, for your purposes, not many, I think only 1 or 2 of you are using Scala. For your purposes, this will probably be socket ID to strings and ints or requests. But whatever it is, however you're identifying each client, you'll have your identifying information there. For my purposes, it's an actor reference. Store the number of bytes I expect to read, and also that request with everything concatenated into it. And then next time I get a request from that same, sorry, not a request, but next time I get some information, a buffer full from that same client, I'm going to hit this line again. Okay, have I read enough information? If I haven't, read some more information. Oh, sorry. This will be false in that case. I gotta go down here. So this will be false. Okay, I have more information to read, and I've already started buffering this user. So I'm going to go to that request, concatenate everything from this request, from this message, to what I already have for that sender, and also subtract what I'm expected to read, the length of what I just read from what I'm expecting to read, and if I'm done reading, this is where I can finally process the request. For this example, I'm just printing it to the screen. No, this is not UTF-8. I'm just doing that so it prints to the screen without giving me 1 line full of bytes. But that's when we can start processing this request. So let's start this server, or restart in this case, and see how this is working in practice. Oh, come on. So let's fill out our form with our file picker. I'm going to upload, let's upload today's slides, which apparently we're not getting through all of them. I'll briefly go through today's. And then submit that form. Content not found because we're not really serving anything. But let me look at what happened when we did that. So first we get our request for the page, request for the HTML, send the HTML, request for the style sheet, send the style sheet. And then I get my post request for the form. I have 95,000 bytes to read from this request. So this is going to overflow my buffer in this case. If it doesn't, then I did a terrible job setting up this example. And I also have my multi-part. We can look at the multi-part as it comes in. And for this request, we see our multi-part setup. And when we get to the file, it does tell me the file name that I did upload, which we shouldn't really be using unless you have a specific use case for that. And then all of the bytes for that file. But when we get down here, we're going to see the end of our buffer. And we're going to get the end of the message. So when I call, when you call receive, whatever library you're using, when you get your first chunk of information, it's going to end mid-request once you overflow the buffer. And then I get another message from that same client that's just a bunch of bytes. Now, if you get this second chunk of bytes that you're receiving and you're trying to parse this as HTTP headers, well, guess what? There's no request line, there's no headers, there's nothing here. It's just more bytes from the previous request because it's still sending that content length number of bytes over the stream. Those need to be read. So we get more information. End of that message, we get another message from the same client. We get another message, buffering, 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 and finally we hit the end, our end token here, and it's the end of the bytes for that. So now here we're at this part of our code where I'm just printing out all the values. I'm printing out the headers, but I'm printing it out as a map so I get all my headers on one line, but just to show that we have that information, the header information still. And then the content of this body. And here we can see it's all concatenated together. I have the whole file all in one big chunk. I don't have those separated bytes. I almost said concatenated together. But I put all those bytes together, and I have that whole file right there. Just bringing it to the screen, but this is where we would do files.write, pass.get, file name.pdf, I guess. I should probably write some information to it. I shouldn't have went for this. Pass.get, sender, body. I shouldn't have went for it. We don't have time for this. Bytes. Well, anyway, that's where the magic would happen, where you save the file. That should have worked. It's gonna bug me now, but you get the idea. That's where we would write the file. Yeah, question? Yes. So TCP is going to guarantee that we get the file in the right order. That's where we would have individual packets with sequence numbers, and those would all be arranged, assembled, and then we get that information. So TCP is going to guarantee, once it's writing those bytes to the socket stream that we're reading from, it will be in the right order. We have that guarantee. So I do, when I receive this body this is the exact bytes that I have in my actual file. So if we look at the way up, this, oh, actually, that's not going to be. That content length, though, is going to be exactly my file size, plus, I have this extra stuff, plus the little bit extra from this. But that's very... briefly, let me just do it in the code. Let's very briefly talk about templates, just so we at least have this information out there. Then I'll go revisit templates on Monday. So templates, we have this problem where we want to serve custom content in our HTML itself. So for homework 3, we're getting around this with just a few kind of awkward setups. When there's no cookie set, we're sending one HTML file. When we have no cookie set, we're sending a different HTML file. But what if we just want one HTML file with a different message depending on whether or not the cookie is set or not? How do we do that when we have these files, these HTML files saved on our hard drive? And the answer is going to be HTML, and the query string. The query string, we get this query information, we're reading it, and then sending a custom response back. Or we're just using plain text to get around this problem. We're just using string concatenation, we're hard coding a response, and then sending that response, getting the content length of it, and sending it back. So we're avoiding this problem in homework 3 with those two approaches. But for homework 4, we're going to have to send all those files. We're going to have to do some custom HTML. So for this, one strategy to do this is to use HTML templates, where we have incomplete HTML files with some placeholder variables in our code. And then when we go to render this template, we're going to send this template with that information replaced with whatever we need. So here I have an HTML template that takes 3 variables, title, description, and image file name. And then if I want to serve this, I can serve that with different content depending on what specifically I want to send to the user or what they're specifically requesting. So I have this path /Discord. And I'm going to take my template and give values for that title, description, and file name, and replace those with specific values. And then I have my templating method here that's going to take the file name, read this file, and then replace those placeholders with their appropriate values. So if I go to /Discord, I'm going to get that HTML file with those values placed in there. And nobody's really been using, I kind of put this message in here, nobody's really been using the Discord. If that's not really useful, I'll watch it for the next few days. Maybe y'all just forgot it existed. If nobody wants to use it, if it's not helpful to the class, I'm just going to shut down that server. Maybe it's just not appropriate for this kind of class. In 116, I have a Discord, and it gets a lot of traffic, gets a lot of chatter, and the students like it pretty much. But maybe at a junior level, that's just not the thing you're all into at this point. So I'll watch it, maybe I'll forget, and I'll check it. If it starts getting traffic, I'll keep it up. But if it's not being used, there's no point in having it, I'm just going to shut down that server.